All right, A&P1 students, this video we are going to continue covering the learning objectives for Chapter 1. So I have a little cartoon here that I thought was humorous, so I thought I'd share that with you before we start looking at our learning objectives. Okay, if you recall the last few videos over Chapter 1, we've been discussing these learning objectives 1 through 9. So now we're going to, this video and another one, we are going to start discussing homeostasis. And so this is, you'll see there's quite a few of those objectives here for homeostasis, and reason being is homeostasis is a very important concept to understand, and it's a kind of a central concept that we'll use throughout A&P. So it's really important to have a good grasp on what homeostasis is. And again, we'll apply this concept to a lot of different body systems and parameters in the body that we want to keep at a certain set point or normal range. Okay, so first we're going to define what homeostasis is. So this is from our textbook, and I've highlighted the definition for homeostasis. Now this goes for other organisms too, but we're going to talk about the human body. So we're going to talk about homeostasis as it refers to the human body and how our bodies are able to maintain this kind of consistent or constant environment internally, regardless of, and kind of in response to any of the changes that are going around outside our body and anything that's going on inside our body. So we, a lot of times we'll refer to homeostasis as a way that our body keeps balance or equilibrium or steady state. That's what homeostasis is. So we have these control systems in our body that will kick in and start, if one of our conditions in our body starts to go away from a set point or away from a normal range, then we have these control systems that'll come in and get it back to where it needs to be, near the set point, towards the set point, or in a normal range, back into the normal range. So temperature is a good one too, and that's usually what we use as our example. So body temperature regulation, our human bodies need to maintain a certain body temperature so all of our cells can function properly. If we get really high body temperature, hyperthermia, or if our body temperature gets really low, hypothermia, then our cells can't function properly, and if they can't function, all of our processes, body processes can't function, and that's going to lead to illness, sickness, and then if it doesn't get corrected, it can lead to death too. So, all right, so that's the definition of homeostasis, and then I kind of explained in there why homeostasis, what the purpose is, and it's to maintain a healthy environment for our cells. So that way they can function properly and complete these processes that are going to ensure our survival. So again, if we have an imbalance in homeostasis, like any of our parameters, whether it's temperature or blood pressure or heart rate, if any of those get out of the normal range or away from set point, we start to feel ill, we're sick, certain body processes aren't able to perform or complete as they should, and then inevitably, if it's not corrected, then we can die from that. So we want to realize that homeostasis is, and those control systems that keep all these parameters at a set point or in a normal range are very important to keep us healthy and to prevent us from dying too. So, all right, so those were the first two objectives, defining homeostasis and explaining the purpose of homeostasis. All right, so in this video, we're also going to describe, when we're talking about that control system for homeostasis, there's three components to every control system in the body that are needed to maintain that homeostasis and control it. So we're going to talk about those three parts. We're going to go back to our textbook here because they have a nice little picture that shows it. All right, so I think I got that all in. Okay, so again, if we have these conditions in our body that we need to keep within a neural range or at a certain set point, our body has these control systems that will make sure that happens. So keep those parameters at a set point or within a normal range. The control systems no matter what parameter we're talking about, whether it's body temperature, blood pressure, heart rate, even like the amount of sugar in our blood stream, all of those, we're going to have like, they're all going to have a receptor, a control center, and effector that are controlling those parameters and keeping them at the set point or in the normal range. So when I say set point, let's say body temperature, usually set point 98.6 is generally the agreed upon set point for body temperature. But realize that like when I take my body temperature, I'm usually, as long as I'm healthy, usually it's 97.5 or something like that. So but there's a range, so you can be, have a normal temperature anywhere from, 97 to, upwards of 99. And then anything above or below that range is considered, out of the range and abnormal. So hypothermia, which is a low body temperature, or hyperthermia, which is a high body temperature. So that's what I mean by set point and normal range. So blood pressure, you guys probably heard the 120/80. That's the blood pressure parameters. That's the set point. Again, some people, it's normal for them to have a blood pressure of 100/60. That's normal, still in the normal range. So we don't get, too worried if people get that low. It's when they, drop below the 100 or below the 60. So that's an example too of set point and normal range. Okay, so regardless, we're going to use this little diagram to just generally talk about those three components that are part of the control system that are going to keep these parameters or conditions in our body at set point. So the receptor is the first part. So we'll have, these are, when we say receptor, control center, and effector, whenever, it depends on what the parameter is. So if it's our body temperature, we have a control system that's going to keep our body temperature in that normal range. So we'll have receptors in our body that detect when our body temperature gets too low or too high. And then we'll have a part of the body part that's going to control that, knows what it should be, and it can make a decision if it gets too high or low. But it usually can't get the body temperature back in the normal range. It has to tell another part of the body, which is called an effector, to do that. And I'll give you examples but just generally the receptor, if we want to define what the receptor does in a control system for homeostasis, it's going to detect a change in whatever parameter. So it may detect a change in the body temperature, may detect a change in the blood pressure, may detect a change in heart rate, may detect a change in the sugar levels in the blood. But that's what it's doing. It's detecting some sort of change. And this is the term a lot of times that you'll see the textbook use for a change. So we'll call the change a stimulus. So stimulus is synonymous with a change in some sort of variable in the body or parameter in the body, whether it's temperature or pressure, levels of sugar in the blood, any sort of change like that. That's what the receptors are detecting. So that's what they do. Now, they generally will need to tell another part of the body that's happened. So that part of the body that they're going to relay that information to, that there is a change, is called the control center. So the control center, majority of the time, is the nervous system or the endocrine system. So those are the two main body systems that regulate homeostasis or control it. So they're kind of the ones that are going to be controlling and making decisions. So it's generally the brain, which is the nervous system. It could be spinal cord, the nervous system, or the endocrine system. And the endocrine system, if you're not yet familiar with that, is all those glands in the body that produce hormones. So like the thyroid gland, the adrenal glands, the pancreas, those are examples of these glands in the body that produce hormones. They're part of the endocrine system. So that's going to be the control center. So once the receptor detects that there's a change in a parameter, it'll tell the control center. And then the control center's job is to take that information, process it. We use the word integrate that information. And then it needs to kind of make a decision. So and initiate the signal to tell some other part of the body to do something about this change, that because we're getting away from set point. So the control center is going to essentially control the response that we're going to have to this change in stimulus or change in the parameter. So then the control center will send information. It'll either be through nerves, because if it's coming from the nervous system, the nerves will take it to another part of the body to communicate, or it could be through hormones. So there could be a gland that when it detects that there's or it doesn't detect, but whenever it gets information that there's a change, then it might release a hormone into the blood, and then the hormone will make its way to the effector through the blood. And then the effector, that's the structure that's actually going to bring about the change. So a lot of times it's muscles, generally. But it can be other parts of the body too. So certain glands of the body too. But a lot of times it's muscles that are going to be stimulated from directions from the control center to do something that's going to restore that parameter back to what it should be, towards set point, or back into that normal range. So these three things, receptor, control center, and effector, you will always have those three components to every homeostatic control system. And it's important I'll ask you questions about what the receptor does, what the control center does, what the effector does, what's the most common examples of receptors in the body, common, systems or parts that are serving as control centers, and again, common parts that are serving as effectors too. Okay, so I'm going to stop this video here, and then we'll continue on and kind of start comparing, or I guess giving you examples of how this actually works in the body. So this is kind of a general diagram, kind of just going over the three parts and what they do, but we're going to apply that to actual parameters in the body and have you guys practice also with some case studies and to help you better understand this process. So I'll see you in the next video.